Okay, this is Continuing Study Guide 10.0, Part 2, and we have gone to number 6. And number 6 looks like this. Now, to me, the most important thing here is to look at this and figure out what's happening. In the first four problems, we were adding and subtracting polynomials. Well, if you'll notice, I have a binomial here. I have a binomial here, two terms. There's no addition or subtraction sign here. These parentheses are just shoved together. That tells me I'm going to multiply. Two terms here is considered a binomial, and two terms here is also considered a binomial. So this would be a 2 by 2, which means when we use our Punnett square, the square is going to be a 2 by 2 square. So we have two terms going this way, and we have two terms going this way. And the reason that we use a Punnett square is because I have to make sure that every term in the first binomial gets multiplied by every term in the second binomial. We could do it this way, but I think it's a lot clearer and a lot better to do it this way. I don't care if you do it this way, but can I caution you to be careful? Because it's easy to get mixed up, and I think this is really clear and really easy to do. So I would lean towards using this for sure. R times R, which is just like this times this, is R squared. R times 3, which would be this times this, that's 3R. R times 2, which would be this times this, is 2R. And 2 times 3, which is this times this, would be 6. Now we combine terms inside the boxes. So we were multiplying all these monomials together, all these terms. When we multiplied, we got all this, so now we're going to put all this together. Now I could write it like this, and I would see that I have 1R squared with no partners. These are like terms. I can combine these and get 5 positive R's. And remember, we're not multiplying. We're combining or adding or gathering all of our R's together. And then finally, I have my positive 6. Or sometimes in class, we just notice that we have 1R squared, so we bring it down. These are like terms. We combine these, and we get 5 positive R's. And my last term with no partner is a positive 6. Either way, this is our final answer. This is in standard form because the highest exponent comes first and the constant comes last. And this is a trinomial in standard form, and my leading coefficient is 1 because that's 1R squared. All right, let's look at number 7. Okay, once again, I'm going to look at this and I'm going to notice that this is a binomial, 2 terms. This is a binomial, it's 2 terms. There's no addition or subtraction. The parentheses are shoved together, which means we're multiplying. So we're going to use a 2 terms in a binomial, by 2 Punnett square. My 2 terms in this binomial are x and positive 3. My 2 terms in this binomial are x and minus 3. I have a question for you. Most of the binomial times binomials that we multiply, we get a trinomial. Will we always get a trinomial when we multiply 2 binomials? I don't know. What's x times x? It's x squared. X times negative 3 is negative 3x. X times positive 3 is positive 3x. And 3 times negative 3 is negative 9. I'm going to add everything inside the squares, and I'm going to get x squared with no partner. hey, check this out. I have 3 positive x's and 3 negative x's. So when I gather up all my x's, those are going to cancel each other out, and I have nothing. But I still have my -9 constant that I need to put over here. Really soon, we're going to learn this has a special name, and this is called the difference of 2 squares. Difference is subtraction. This is a square number, and this is a square number. But this is the answer for now. It's in standard form. Highest exponent first, constant last. The leading coefficient here is +1. Number 8. Okay, this is 2 terms. Each term is separated by an addition or subtraction sign, so we have a binomial times a binomial. So that would be a 2 by 2 Punnett square. My 2 terms in this binomial are 4x and +4, and my 2 terms in this binomial are 4x and +4. Just interesting here. Aren't these exactly the same? Could that have been written like this? Isn't this just 4x plus 4 times itself 2 times? I just show you that because that's going to be coming up real quick. Okay. 4x times 4x is 4 times 4, which is 16. X times x, which is x squared. 4x times 4 is 4 times 4, which is 16, times x. 4x times 4 is 4 times 4, which is 16, times x. And 4 times 4 is 16. I wonder if our x terms are going to cancel out like they did last time. This is my only x squared term. If I gather up all my x's, well, wait a minute, those aren't going to cancel out because they're all positive. Positives and negatives cancel each other out. There are no negatives here. So when I gather all of my x's together, I have 32 positive x's. And my final term is a constant of 16. That's my answer. It's in standard form. None of these can be combined to simplify it, and my leading coefficient is 16. Now, number 9. Actually, I'm not going to do number 9 right now. I'm going to throw in something else that wasn't on your study guide, and I want you guys to write this down and do it. I want you to put x squared plus 3x minus 1 plus negative 2x squared plus 3x minus 4. We'll leave it at that. Okay, I'm adding 2 trinomials. We're adding, we're not multiplying. We're not going to use a Punnett square, a Punnett rectangle. We're going to add, which means we're going to distribute a 1 here, a 1 here, and then we're going to combine like terms. So I have x squared plus 3x minus 1. None of these changes its value. It's just being multiplied by a positive 1. And also here, none of these will change their value because, and that should be a negative, because they're being multiplied by a negative 1. So this should be negative 2x squared plus 3x minus 4. When I combine my like terms, this is 1 positive x squared, so if I have 1 positive, 2 negatives, I'm going to have 1 negative left over. I have 3 positive x's and 3 positive x's, that's positive 6x. And if I have 1 negative here and 4 negatives here, none of them are getting married, that's negative 5. Standard form, None of these are like terms. It can't be simplified. My leading coefficient is -1. I'm going to throw in another one that wasn't there. This is what I meant to do last time, but I kind of screwed it up. I want you to put x minus 1 binomial plus another binomial, which is going to be 2x minus 2. But I'm going to put another binomial here, and it's going to be x minus 3. So you have to ask yourself, what am I being asked to do here? This is a binomial plus another binomial